Having the ability to change between different work coordinate systems is a very powerful tool. Now, if you're a CNC programmer, you know exactly what I'm talking about. But if you are a hobbyist, then chances are that you don't use those commands. Now, unfortunately, this is a really dry topic, and you just have to struggle through the first section of this video where I try to explain what those work coordinate systems offsets are and how they work. So it's a little bit dry, but I promise if you struggle through it, it's going to be an aha effect, and I hope that this command can actually be a really big benefit of how you use your machine. So that's coming up in this video right now. And the best part is you don't have to download anything or purchase anything in addition. The commands that we are using to utilize different work coordinate systems are already built in. They are a portion of your controller. See, all of the controllers use a little bit different dialect of the G-code commands. So therefore, it doesn't matter if you have a Heidenhain, a Haas, a Tormach, or a Planet CNC controller, or in my case, EdingCNC. Even Gerbil can utilize the G54 through G59 commands. So just in case you have no idea what I'm talking about right now, let me give a short example. So we have the ability to put different workpieces on our machine, and we can hold them the same way, or different work holding systems, and every single workpiece will get a new coordinate system assigned. So XYZ0 will be new for every single workpiece. The advantage is that we now can hop from one part to the next part to the next part, and we can clamp several parts at once in one machine setup. We can even optimize that further. We can say, hey, phase all of those first and then make all of the text, and then let's say we create a sign and we route the sign out. This will minimize your tool changes. You see easily how powerful this is and how much efficiency gain there is by using different work offsets. So when you start up your machines, then usually G54 is the default work coordinate system. So if you now zero out your workpiece, then you have zeroed out or assigned G54. But we have more than that, and most controllers allow between G54 and G59 the different work coordinate systems, so there are 6 of them. Here the important is that often there's a reference made, so if I talk about work coordinate system 1, then that would be G54, number 2 would be G55, and so on. So we have 6 different ones. That's not all. On EdingCNC, for example, the G59 command allows me to choose yet different ones. So it's G59.1, G59.2, and so on. So check in your handbook for your controller. Chances are that you even have more than 6. But hey, if you only have used 1 so far, then I would say 6 is pretty good. Here I've prepared an example for you. I have 2 workpieces on a pallet. And the pallet always goes in the same position on the table. So you can say also that is your mod vise right here, and you always put it back in the same spot on your pallet or on your table. And maybe back there would be a regular vise that always goes in the same position. What you can do then is call out a work coordinate system 0 on a specific feature of that clamping system. So on this pallet, I always have the front left-hand side as 0, and I align my piece, my work piece, here just by feeling it like so and then gluing it down. And these are spindle brackets, actually the upper spindle bracket that I have to make. That is rear and front. So this one I'm going to call G55. And this one here, I'm going to call G56. So let me show you how we do that in the controller. And the first thing that we need to do is that we are going to set the position right here. So our bit will need to be in that position. So I'm going to move X over, Y over, Z down. And let's just say for a moment that I don't want to get too fuzzy about it. So this is now perfect 0 right here and right there. Okay, so we're going to call that a 0 for our first work coordinate system. This is G55 we said, so this will work will be work coordinate system number 2 if we would enter it into any programming. So, but it's G55 as a reference. Now we're going to zero that out in Edding, and this is the operating screen of my controller, EdingCNC, and I also have a tab for coordinates, and I can calibrate up here, calibrate and activate a coordinate system. You have to just find these buttons on your system, but they're going to be there because, like I said, this is very common. If you don't have them, I'm still going to show you a method how to do it in a moment. All right, so number one, first is we need to activate the right coordinate system. We said the front one is G55. That's where the tool is right now. So I've activated G55. How do I know that this is active right now? Well, if I go here on the right-hand side of my controller, it gives me a whole slew of G-codes that are all present right now. You see here G90, G94, and after that G55. That is what we just activated. And now, since our tool is already in the right position, I am going to hit calibrate here on G55. It's going to ask me, are you sure? Yes, I am. So also take note now, our X, Y, and Z 0 has zeroed out. So my DRO just changed and everything is set to 0. Go to coordinates again. I want to now activate. First, you need to activate the right system, the right work coordinate system. So this is G56 now. And see my DRO, all the numbers in the DRO have changed because they are still in one of the older settings for that G56. But if I now go to calibrate G56, I'm going to go ahead and calibrate it right here. Are you sure you want to calibrate this position to G56? Yes. My DRO changed now again to 0. And I can see down here, if I read these numbers, that now my active system is G56. Okay, and here comes the magic. Let's go back to the operating screen. And let's open an MDI. So manual data input. I have that right there, and you can see I already did a bunch of adjustments here or tests. So I'm going to go back to the G55, so the front part. All I have to put in G55, enter, and now my G55 is active. Again, how do I know that? Because now on the right-hand side, I see that G55 is active right here. So now I will just hit G0, G0, X0, Y0. So what should happen? Our tool should move to the front right-hand position right here and show us 0 in the DRO. And there it is, and our DRO is 0. Now, let's say we phase off or make our holds or whatever we need to do on the first part. And now we want to use the same tool to also do that operation on the second part. So I don't want to do a tool change. Well, what would I do? I now go to G56. I hit enter. All my DRO has changed. I have G56 active right here. And what I can do now is again go G0, X0, Y0, and I now go back to the work coordinate system of the second part, G56, and I can now use the same tool to do my tool pass for that tool in the second part. Or alternatively, could just machine the first part completely over, so all of the operations, and then go to my second part right here. Or the part could be flipped. So you see there's like a lot of different options where this could be used. In case you're using Fusion like I do, I can show you how we can prepare the G-code already with the correct work coordinate system if you have multiple parts. So 3 times a vise on your table for an example. And here I have part number 1, 2, 3. And I made a setup right here. And you see on the setup I have the work coordinate system in this corner, which is the fixed side of the jaw. and then Z is on top of the part. Okay, and I did that for all 3 parts. Now, when you clamp this on the table, the important to know is that you're going to zero out your controller like I showed you. So this would be G54, G55, G56. And when you zero that out, you basically have given or assigned a 0 point, your work coordinate system, for every workpiece. Now, you see the spacing here in between the parts. That is totally not important how that looks in Fusion, because it's only important how it looks on your machine. And if this would be 10 millimeter here and on your machine 100, or here 100 and on your machine 10, it does not matter where this is. In the moment you zero out the workpiece up here, then it knows exactly for this work coordinate system where your part is. Okay, so what if you like to do it like I showed you in the video before? This would be 54, 55, and now I'd say, okay, how can I make this work coordinate system 55? Well, this is set up for here in my instance. I right click it, I say edit, and I'm going to click post process. Here in post process I have the machine work coordinate system, and there's an offset. So remember that I said G54, the reference for that is always 1, and G55 is 2, and so on. So I want this here to be number 2 now, because I want it to be G55. All right, I'm going to click OK, and now I have assigned this work coordinate system, or this part, to work coordinate system 2, G55. So in my setup number 3, which is the first part, here's my coordinate system. I'm going to right click on it, edit. And here I have the post process. I have a work coordinate offset. And in the moment, which is 1, in the moment where I set the tick mark for offsets, I'm going to check that. Number of instances, well, 3, because we have 3 parts. And work coordinate offset increment is 1. So what does it really mean? Well, it means that from work coordinate system number 1, it counts always 1 up. So it's going to count G54 to G55 to G56. Okay, and I'm going to click OK now. So this is set, and we can make a simple facing toolpath, which I already prepared right here. And let's have a look what happens if I simulate that. Okay, it is 1 that is applied to all 3 parts. And let's see, I'm going to go ahead and simulate that with the machine. And there it is. And now I am going to hit the start button and see. First part done, it should move over to the second part. And it doesn't. So it only went through this toolpath 1 time, but I have saved this program already. It's right here, and it's called Face Test 1. And we can also simulate this toolpath. So right click, hit simulate. And now this is not the toolpath we're simulating, this is now the NC program, the one that we posted. And remember, we set the work coordinate system up for 3 parts. Okay, let's simulate this again. All right, it's doing the first part. That's nice. Well, dang on, it's doing the first part again for the second time. And for the third time. Well, it should be going over to the next part and the next part, right? Well, it doesn't. And let me show you how it will look like on the machine, actually, by looking into the G-code. All right, so here we have a look at the G-code itself. So this is what you will ultimately run on your machine. And we have a few parameters set up front, and we have phase 1. Phase 1, and here is a G54. Do you see that in line 13? That is program line number 45. We have a G54 set right here. Okay, that would be the first phasing. Well, then we have phase 1 again, same, because it's phase 1, because it's the same toolpath. But now, let's have a look. We have here a G55 called up. So this G55 will automatically move to the second part. All right, well, here we have phase 1 again, and lo and behold, there it is, G56. So our program is going to do the correct thing. If we simulate this now in our controller, it will actually machine 3 phases in 3 different positions. So let's do that pretty quick. So here I'm in EdingCNC and I'm in the simulation mode, but that doesn't matter. So you can see that we have 3 toolpaths here, and they are the surfing toolpaths. Now the interesting thing is that you can see they are not aligned at all like in Fusion with the 3 vices that we have. Matter of fact, this is the first toolpath here in the front. Then it's going to go to the rear right hand side. So basically this toolpath here, that will be number 2. And then number 3 actually will be this one here in the middle. So I've even flip-flopped the orientation or the sequence, if you will. And when I now simulate this, you'll see that we're going to start at the front. We have to load the tool, and then it's going to go to the first toolpath right here. And I'm going to just make that a bit faster. And I'm going to let that play through. And now watch what happens. It goes to the second one, but that's the one back here. And we're going to phase that part now. And once it's done with that one, it will go to the middle part here and phase it. So you see that the distance and the position is completely dependent where you zero out the workpiece on your controller, not where it is in Fusion 360. So I hope this video was useful to you and you could learn something from it. If you did, would you please leave me a thumbs up, and I will catch you in the next one. Take care. Bye.